Respected Chief Secretary Dr. Venu, the IT Secretary Dr. Ratan Kelkar, the Planning Commission member Tirunamashivayam, co-founder of Infosys Shri Shibulal, the chairman of IBS Software Shri V.K. Matthew, managing director of Zafin Srimati Suja Chandy, the Vice Chancellor of the Digital Science, Innovation and Technology University, Dr. Saji Gopinath, and the many officers, dignitaries, executives, students. Good morning to you all, and thank you very much for inviting me to be part of this celebration of the intellectual traditions of Kerala, where you always have such conferences and literary festivals on a regular basis. I often joke that though I'm a minister in the neighboring state of Tamil Nadu, at least 2 or 3 times a month I get invited to Kerala, and at least once a month I'm here. So I'm an honorary citizen of Kerala. I didn't have any particular topic given to me for today, so I just want to talk about a few things, and you'll be spared of my speech for not very long because I have to be back at the airport relatively soon. But I think in this age, we are in a very inflection point, one of these S-curve shifts in technology. And in this period of volatility, of transformation, it might be worth first looking backwards and then looking ahead. For somebody like me, computers and my life have almost grown in parallel. For those of you who may not remember because you're so young, the concept of the personal computer only dates to the 1980s. So after many of us were born on the stage. And when I was a graduate student, getting access to a machine or undergraduate student at NIT Trichy to even do my undergraduate thesis required you to book a slot and get time. There was no concept of having your own computer. But at some level, computers have always been about 2 things. One, about processing information, being able to handle, store, provide continuity, do analysis, get insight, make predictions, transform processes in some way using this wealth of information. So if it's information technology, you start with information and then you do something with it that makes you do some other process you otherwise used to do, or maybe you never used to do before, better than you otherwise would have. And I remember when we first started getting the notions of high capability text processors. Till then, we used to get all of our PhD dissertations and master's research projects typed up in a regular typing machine, and then editing was taking forever. And once even you had PCs, the Microsoft Word was not capable of parsing and formatting and sequentially reorganizing, let's say, a 300-page dissertation. And the technology kept getting better and better and better. And if I look back at the stages of transformation or evolution in my own time, I would say the birth of the personal computer stands out as a landmark, let's say 1980. The birth of propagation of high volumes of graphical user interfaces, that is, the kinds of screens we take for granted now, whether it is Microsoft Windows or the Apple Mac interface or all the Android interfaces, the phone interfaces, probably around 1990. That's when they started getting widespread. As late as 1992, 93, all you had was some bits and pieces of email, like a BitNet for the universities and ARPANET for the defense institutions. There was no standard for IP protocols. There was no real internet to speak of. So that revolution, I would say, was the third one around the late 90s, towards the turn of the century, the first dot-com boom, when you started seeing the effects of what in economics you'd call network externalities, but effectively bringing all kinds of people together. That turned out to be economically a bit of a crash. But in parallel, the industrialization of technology was taking shape. And I remember the birth of the first ERP systems, those that are ubiquitous today, even for small businesses, and certainly existentially vital for large organizations and businesses. The notion of enterprise resource planning is only about 30 years old. It wasn't a long history. And then you had the resurgence after the dot-com and the notion of distributed servers and the development of server farms that eventually became data centers, the processing through high-speed access of video content, and the revolutions just kept coming after that. But where we are now is probably a transformation that makes all of the old revolutions or old transformations look relatively insignificant. Because now we have, through the cloud and through access to relatively, limitless or marginally zero cost capacity to create, store, analyze data, we are at a stage where we will no longer be limited by computing capability or memory capability. We will be only limited by imagination and how well we can humanize these tools to deliver better outcomes. In particular, the Planning Commission member spoke about an approach to IT. Just because the tools exist doesn't mean everybody uses it the same way. Social media uses, companies use it for something else. Companies that use it for profit do it some other way. As far as governments are concerned, I think there's a very high level of synergy between the approach of the government of Tamil Nadu and the government of Kerala, and I say this apart from politics, whichever government happens to be in effect. One is that we should use the technology to improve governance and the interconnect between the government and people. And this is the transformation of what used to be manual processes, what used to require a lot of in-person interaction into either automation or faceless online transactions, and removal of the need for people to travel, the risk of rent seeking, the risk of any kind of malintent or bad behavior, and the great increase in throughput or efficiency of how many things the government can do well for how many citizens in a day, in a month, in a year. And the second aspect of it, I think, is inclusion, and in these days particularly education. So much of the world's knowledge is now available online that having access to relatively high-speed connectivity is a distinguishing variable of whether one is truly included in prosperity, in access, in growth. I was earlier with a delegation to come and look at the KFON project, which one of our former IAS officers, Thiru Santosh Babu, is leading very efficiently. And I think it's a model for all of us, that if we can connect every house, every village to relatively high speed, and by relatively high speed I mean you can see video content without breaks. Because so much educational content is on video, and though there are many downsides to video content, the one real unique benefit of video content is in learning. No other medium of teaching conveys the same level through the student as video. No amount of text or demonstrations or graphics or podcasts. Video somehow seems to be able to recreate the human-to-human connect, and we are able to get that kind of traction. Now, there are limits to that, because if you look at the COVID period, in theory we were all running online classes, but in practice many houses did not have connectivity, many houses did not have enough room where a family could sit in one place and yet allow child A to be taking classes somewhere else and child B to be taking class somewhere else. So we discovered during COVID that access without needing cell phones or without needing very expensive devices and access to space are actually hugely important to achieve our ambition of social justice and inclusion. And so, for example, though we started late compared to many other states, our ambition in TanfiNet now, the Tamil Nadu Fiber Network, is by this time, this next year, to connect all our 12,600 and odd gram panchayats to 100 Mbps fiber through our project. And we think that is core to our philosophy. I want to talk a little bit and last about the advent of artificial intelligence and its true implications, particularly for governments and our processes. Back in the day when I was a graduate student, my PhD dissertation was called, let me think, what was it called? It's called Individual Differences in Cognitive Processing and its Implications for Computer Interface Design. So that's basically what we were doing in the late 1980s, right? When we were building interfaces and we were trying to understand how is it that this machine that is capable of doing, 5 million different things with the same chip and the same screen and one mouse and one keyboard, and we are trying to bring different kinds of people who will want to use it for different things like creating graphics or running spreadsheets or playing video games or doing analysis of microbiology. How do we get them to understand how this machine works, realize its potential and utilize it in the way that they would like to get the maximum output? And this was a big field back then in the late 80s, early 90s, is how do you design interfaces? So on the one hand, they're intuitive, they don't need any special learning, special training, special programming language to learn. And on the other hand, they can be made to do the output or the work or the process that the individual wants. Why I say that is we are at the exact other end of the technology today, the spectrum. At one time, we used to train people on how to use the machine, and we used to do research. How can we train people better, or how can we design the machine so that they require less training? And my best definition of artificial intelligence today is that now we are training the machine on how to understand people. We are no longer training people on how to use the machine. We are training the machine on how to understand people in their everyday interactions, how they normally speak, the questions they would normally ask, the expectation of an average person when they are seeking information or an answer or a particular outcome based on some intent. In fact, a couple of times last month, I was at events with my friend Rajesh Nambiar, the chairman and MD of Cognizant, and at one of them he asked the question, one sponsored by our government of Tamil Nadu's training academy. He asked the question, what is the most common programming language in use in the world today, most used? And all kinds of people came out with all kinds of languages. And he said, no, today the most common programming language is English. Because what most people are doing is figuring out how to write the prompts that will make the machine learning models work, the large language learning models work, so that they can figure out how to interpret unexpected, unplanned. So the notion of generative, the notion of emotive AI is actually driven completely in the English language. That to me is the transformation that AI brings. And how we really should think about it as governments is that, when I was doing my interface design research, there used to be a famous professor at the MIT Media Labs, and his benchmark for how to design some device, some interface, some input-output gadget was, will my grandmother in Ohio be able to use this without training? That was the benchmark. Now we say, if the AI is good, then the question by some grandmother in Kottambatti should be understood by my machine from the government of Tamil Nadu and answer her the question, what do I have to do to get treatment for this illness? Or am I eligible for this benefit from the state of Tamil Nadu? That's really the way we think AI should be applied in government processes and government transformation, and we are just starting to scratch the surface. Yesterday or day before, I opened the Chennai expansion of one of the largest enterprise AI companies in the world called Unifor. It was a company incubated in IIT Madras, and it has now grown to a valuation of about $2.5 billion, offices in many countries around the world, and they have just put in their R&D and innovation center, 250 new seats, back in the place where they were incubated from. And they can process 100 languages worth of communications directly into the machine. And so the one they showed me was a lady speaking in Arabic to do her banking transactions with a Saudi-based bank. And that's their engine that is helping her do her transactions without needing a keyboard, without needing a mouse, just a touch screen and voice basically going through her transactions. That is the transformative power of AI, and I think we are just at the starting of what might be finally the actual coming of AI. For most of you who are my age or thereabouts, this is the third or fourth great coming of AI. But what distinguishes this avatar, this rebirth, is, as I said, the almost unlimited access to computing capability on demand. You don't need to buy a 100 million computer to have access to $100 million worth of computing power for 3 hours. You can just get it off the cloud. So that kind of ability to source is going to spark the kind of innovation. And the only other thing that's required is large amounts of data. Now, some companies already have it, but in fact, if we are smart as governments, whether it's Tamil Nadu, Kerala, or India, in fact, the government is the largest repository of data. We are the people who, or the institution that deals with the most number of people, with millions and millions of people through all aspects of their lives, from their birth to their death. Everything is recorded with the government in some way or the other, or ought to be. Whether those records are digitized, whether we can strip the actual identifying information from them so we respect privacy, these are all the issues we have to work out. And in fact, our track record is not good. In case I sound too much like an optimist, one of the institutions that I have seen in my 30-year professional and now 7-year public service career that has the worst continuity is a government. If I ask Chief Secretary how many departments he's been in and how many of those departments' files for the last 50 years are computerized, I hope the answer is better than in Tamil Nadu. I can only say that. So every time an officer changes, every time a minister changes, every time a government changes, we lose so much continuity. A lot of these things are just left behind in people's memories and papers. And we need to really transform the government and the processes first. But were we to do that, then we would have this rich source of data that is unbeatable. You combine that with some computing power that we can generate through many ways, donors, funding, however we do it, and we can actually drive the AI revolution from the governments, which is a rare opportunity for us. And I hope that in the years to come, when such meetings happen again, we'll have some success stories to talk about how we took advantage of this wave of innovation. I'm sure you've all heard of the S-curve model of how innovations kind of, many of them come around. We're still trying to find out whether it works or not. At some point it works, it accelerates steeply, then it reaches maturity and it starts to die off and the next S-curve begins. I truly believe we are in the multiple S-curve starting point now, whether it's deep tech, whether it's IoT, whether it's cybersecurity, whether it's AI. We are, because of this marginal zero cost to store data, marginal ability to harness huge amounts of computing power for short periods of time, we are, I think, in probably the most transformative era of this sector, of this whole field, at least in my lifetime, where I've already seen 3 or 4 major transformations. And it's going to be an exciting time. And for those of us who get to play a part in it and drive it, I think it will be the most fulfilling and satisfying thing that we would have done in our careers. And so I wish all of you, because I assume you're some way connected with the field, whether commercially or in government or as students or as NGOs, I wish you all great progress, great success. I wish this event to be impactful, to contribute to the learning of many from the many distinguished speakers who are going to be here, the discussions. I thank the organizers for inviting me, and I thank you once again for listening to me. Thank you.